So, have you ever really stopped to think about what a skyscraper, a book, and a simple ice cube might have in common? It seems random, right? Well, today we're going to go on a pretty wild journey, from the tiniest particles you can't even see, all the way up to massive power mass. We're going to uncover the hidden science of stuff and see how our entire world is built, right from the ground up.
I know. It sounds like the beginning of a bad joke. An ice cube, a book, and a skyscraper. But the answer isn't a punchline. It's actually a really fundamental principle of science. And stick with me, because by the end of this, you'll see exactly how they're all connected. It's pretty cool. To figure this all out, we need to start small. I mean, really, really small. We have to zoom all the way in to look at the unseen building blocks that make up absolutely everything around us.
And all that stuff has a scientific name: matter. The definition is actually super simple. If it has mass, if it has some weight to it, and it takes up space, then guess what? It's matter. The solid phone in your hand, the coffee in your mug, even the air you're breathing right now, it's all matter.
Okay, so here's the first big idea you got to get your head around. Matter isn't one solid thing. It's actually made up of zillions of tiny individual particles called molecules. They're all buzzing around and interacting on a scale that is just way too small for our eyes to see.
And how these little molecules behave, how they're arranged, and how much they move, that's what gives us the three main states of matter. In a solid, they're all packed together, locked in a tight grid. In a liquid, they're still close, but they can slide past each other. And in a gas, they've got tons of energy and are just bouncing all over the place.
But here's the thing: matter isn't stuck in one state. It can transform. And the secret ingredient for that change is energy, usually heat. When you add heat, you give those molecules more energy, and they start breaking free. A solid melts into a liquid evaporates into a gas. And if you take that heat away, you just reverse the whole process.
Now, if you want to see these transformations happening on a truly massive scale, you don't have to look very far. We just need to check out one very special substance that's constantly cycling through all three states all around us, every single day: water. The water cycle is basically a perfect planet-sized demonstration of these changes. You've got the sun's energy blasting the oceans, causing evaporation. That's liquid turning to gas. Then that water vapor rises up, it gets cold, and it condenses back into tiny liquid droplets to form clouds. And when those droplets get heavy enough, gravity wins, and we get rain or snow, precipitation.
And what's absolutely incredible is that this whole thing is a closed system. The total amount of water on our planet never, ever changes. It's just recycled, over and over again. The same water molecules have been here for billions of years. Seriously, think about that. The water you drank today could have been sipped by a dinosaur. How wild is that?
All right, so we've seen how matter does its thing out in nature. Now let's switch gears and talk about how we humans harness it. This is where we get clever, turning all that raw stuff into the useful things that build our world.
So we start with raw materials, the stuff we literally pull right out of nature. But let's be real, a tree isn't a book, and a lump of clay isn't a coffee mug. That's where processing comes in. We change their properties, we reshape them, and we turn them into the building blocks of our civilization.
Take a couple of examples. We can take a tough, raw animal hide, and through a process called tanning, we totally change its molecular structure to create soft, durable leather. Or we can take the strong, rigid structure of wood, break it all the way down to its basic fibers, and build it back up into something totally new and flexible: paper.
And that process for paper is a pretty amazing feat of engineering. You start by chipping up wood, then you cook it down to get this soupy, fibrous pulp. This is also where recycling comes in. You can mix in old paper and cardboard. Finally, you press that pulp flat and run it over hot rollers to dry it out, locking all those fibers into a brand new sheet of paper.
Okay, so we've gone from molecules to materials. Now it's time to scale all the way up. How do we take these processed materials and build really big things that don't just fall down? Well, it all comes down to understanding the secrets of strong structures.
The key concept when you're building big is something called strengthening. It's basically the science of taking a material or a structure and making it way more resistant to bending, breaking, or collapsing. It's all about turning something flimsy into something formidable.
And you see a super simple version of this all the time. Think about a flat piece of cardboard. It's pretty weak, right? You can bend it easily. But now, fold that same piece of cardboard into a box. Suddenly, it's way more rigid. It can actually hold weight. The material is the same, but changing its shape, its geometry, gave it a whole new level of strength.
Now, for really large-scale structures, engineers have a geometric secret weapon, the triangle. The technique is called triangulation. See, a square or a rectangle can be easily squished and flattened, but a triangle, it's naturally rigid. Any force you put on it gets distributed evenly down all three sides, which makes it incredibly strong and stable under pressure.
And once you know to look for this, you will see triangles everywhere. Seriously, look at the lattice of a huge power mast. Look under a bridge, or at the giant arm of a construction crane. That hidden skeleton of triangles is what's giving those massive structures all of their amazing strength. But combining smart shapes with local materials isn't some new idea, it's ancient wisdom. Indigenous architecture is just full of these genius principles. Take the dome shape of a Zulu beehive hut. It creates this incredibly strong, self-supporting structure using nothing more than flexible trees and woven grass. It's just a perfect example of brilliant engineering with nature. And that really brings us to the core idea, doesn't it? From the way molecules dance around in a drop of water, all the way to the rigid triangles holding up a giant tower, our entire world is built on the exact same fundamental rules of science. So let's circle all the way back to our riddle from the beginning. What's the connection between an ice cube, a book, and a skyscraper? Well, now you know. It's the science of stuff. It's the journey from particle to product, from shape to strength. So, the next time you look at the world around you, don't just see objects. See the incredible science that's holding it all together.